Hey guys, how's it going? We are back again with a new set of videos for you guys. This time we are looking at chapter 4, more specifically chapter 4a. But in this chapter, we're going to go ahead and delve a little bit deeper on our topics of parallel and perpendicular lines, angles, and things like that. But in order to do that, we're going to have to go ahead and apply it to some new concepts, and those being triangles. Alright, so we're going to delve deeper into triangles as well. But before we do that, we're going to have to go ahead and do a few things with that. So first off, in this lesson, we're going to go ahead and classify triangles by their sides using the distance formula. Again, something we've already done in the past. And then we're going to go ahead and determine whether or not a triangle is a right triangle by using the slope formula. Okay. Once again, we have used the slope formula, so that is also nothing new. We're just applying it to a little bit different of an idea here with triangles. All right, so let's go ahead and get started right away. First off, let's define what it is to have a scalene, an isosceles, and an equilateral triangle. So a scalene is when we have all three sides of a triangle that have different lengths. So when all excuse me, woo. Um, so if we have a scalene triangle, that means we have a triangle with all different sides, such as this. Okay, so if this triangle in particular had one side that had a length of 1, the other has a length of 3, and the other has a length of 5, obviously none of those are exactly the same, meaning we have a scalene triangle. All right, moving right along, we have an isosceles triangle. We have two sides of the triangle that are congruent. In other words, they have the same length. Okay, so if you have a triangle just like this one, notice we have these two little tick marks on each one of those sides. That's because both of those sides are congruent. They have the same length. Same exact thing with this example. Both of those sides have the same length. The other one might have a little bit longer, a little bit shorter. It doesn't matter. As long as two of them have the same length or are congruent, then we would consider those isosceles triangles. And then finally, we have equilateral triangles, and I'm sure you guys are familiar with these. That's when we have all three sides of a triangle that are congruent. And once again, all that means is that we have the same length. Okay, so this one, that side, and that side, all three sides have the exact same length, being symbolized there by that little tick mark. All right, so let's keep those three things in our head as we do the following problems. And actually, I like this problem because we're going to kind of go back, take it all the way back to what we did in chapter 1 and include some of those concepts in here. So let's go ahead and read through the directions. It says, find the measures of the sides of triangle KPL given vertices -5, 9 for K, 2, 1 for P, and -8, 3 for L. It says classify the triangle by its sides as either equilateral, isosceles, or scalene, and then explain why. All right, so we can do that. Let's go ahead and do that, guys. So first of all, we're going to have to graph this thing. So let's see. -5, 9 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is K. And then let's find P. So 2, 1. This is P. And then finally -8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3. This is L. And if we go ahead and connect all of our dots, we can make our triangle. Now, we can't really decide whether we have equilateral isosceles or scalene just yet, because we really don't know what those lengths are. I mean, we can kind of make out which ones look like they're similar, which ones look longer, which ones look shorter, but we have to have solid detail, solid evidence of why this particular triangle is equilateral isosceles or scalene. But in order to do that, remember, we need to know if the lengths are the same. We need to know if the distance between those 2 points, in other words, the lengths, are the same. So why don't we go ahead and calculate what the distance is of KP? What's the length of KP? Well, we know how to do that, guys. Remember, we have our distance formula. Go ahead and write it up here. D equals the square root of, hopefully you guys remember this, x2 minus x1 squared plus y2 minus y. Okay? Hopefully you guys still remember that formula. If you don't, remember this is stuff from chapter 1, so go ahead and make sure you watch some of those videos regarding the distance formula. Alright, let's go ahead and do the first one. So I want to calculate that distance. Alright, so what do we have? We have 2 minus negative 5 squared plus 1 minus 9 squared. Alright, this is actually going to be, well, let's see, 2 minus a negative 5, that's really a 7. So this is 7 squared plus, and then 1 minus 9 is a negative 8 squared. And if I calculate all that out, I'm going to get 7 squared is 49 plus, and then negative 8 squared is a 64, which gives me a total of 113. So the square root of 113. And I'm actually going to stop there. I'm not going to go further and actually type that into my calculator. All we really need to figure out is whether or not these lengths are the same. So you can leave it like that. All right, let's calculate PL. So the distance of PL. I just like doing this because it speeds up the process a little bit. But let's go ahead and see. So P is my x1, y1. L is my x2, y2. So we have negative 8 minus 2. And then we have 3 minus. Okay. Let's go ahead and figure this out. So this is going to be negative 10 squared plus 3 minus 1 is a positive 2. Just like that. And then we're going to get, let's see, negative 10 squared is 100. 2 squared is 4. So this is going to give me 104. So right away I know for a fact I cannot have an equilateral because those two aren't even the same. Alright? We could possibly still have an isosceles though, so let's find the length of LK. Okay? Alright, let's do it. So LK, so distance equals, remember, x2 minus x1. So I'm going to have negative 5 minus negative 8 plus, and then we're going to have 9 minus 3 squared. All right, negative 5 minus a negative 8. Remember, this turns into a plus here. So this is really going to be a positive 3 squared plus 9 minus 3 is 6. So 6 squared. And then I just go ahead and calculate. What's 3 squared? That's 9. 6 squared is 36. And if I add those up, this comes out to be 45. So I have all 3 of my lengths there. Now, what do we notice then? Well, none of those are exactly the same. So not only was it not equilateral, it's not possible to have an isosceles since they're all different. Meaning that we have what kind of triangle here? We have a scalene. And we'll go ahead and answer why. Because the triangle is scalene. Use complete sentences here. Triangle is scalene because all three sides have different lengths. None of them are congruent. So because all three sides have different lengths. Okay, so again, guys, this formula is going to come in handy. You're going to need this for this particular section, so make sure you remember that. Whoops, square here. Okay, so x2 minus x1, square that, and then plus y2 minus y1, and then square that. Okay, cool. Let's move on to the next one. Let's see. It says find the slope of each side of KPL to determine if the triangle is a right triangle and then explain why. Okay, well the good thing is that we have a diagram of our triangle and we have it on the coordinate plane, so it's really easy to find my slope. If you guys remember, slope is just the rise over the run. So let's look at it. So the first one we're looking for is, whoops, sorry about that. The first one we're looking for is the slope of KP. So KP. So from K to P, I'm going to go down 1, 2, 3, 4, 5, 6, 7. Actually 8. Okay, so down 8. And then to the right, 1, 2, 3, 4, 5, 6, 7. So negative 8 over 7. Okay, that's my first slope. My second slope I want to find is the slope of PL. Okay. I'm actually going to go from L to P. And again, if you're not sure what I'm doing here, all I'm doing is counting here, guys. I'm going to go down 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 10. So down to right 10, that'll reduce to negative 1 over 5. So that is my slope. Okay. And I'm actually going to redo this so it looks a little nicer. Alright, those are my two slopes. And then finally, I want to know my slope for LK. So I'm going to start from L. I'm going to go up 1, 2, 3, 4, 5, 6. So up 6 and to the right 1, 3. So my rise over run is 6 over 3, which just reduces to 2 over 1. And again, you might say just 2, but I like to keep them as fractions. So the question now becomes, is triangle KPL a right triangle? Yes or no? Okay, I want you guys to think about that for a second. Right? What do we know about a right triangle? First off, a right triangle is only made when we have what kinds of lines? It's a specific name that we have of the lines that we call, and those are the only ones that will ever give you a right angle. Okay, and hopefully now you're saying that those are perpendicular lines which you would be right. And in the previous unit, well, we said that perpendicular lines, remember this little symbol there, a little upside down T. So perpendicular lines have opposite and reciprocal slopes, meaning if it was negative, it's now a positive, and it's the exact flip version. So if it was like 1 over 2, it's now 2 over 1. So we have to compare all three of our slopes here. This one, and this one. Okay, Well, negative 8 over 7, the other numbers don't even have an 8 or a 7. Nope, nope, nope. They are all completely different. None of them are opposite and reciprocals, so no. So you would say, for your reasoning, is that none of the slopes found are opposite reciprocals. Oops, I spelled that wrong. Reciprocals of one another, or of each other. Whatever you want to say, of each other. So none of the slopes found are opposite reciprocals of one another or of each other, and so this is not a right triangle. Okay, again, remember, the only time you can have a right triangle or even just a right angle is if you have two lines that are perpendicular. Okay, and when we're dealing with perpendicular and slopes, we need to have opposite and reciprocal slopes, which this particular problem did not have. Okay. Alright guys, let's go ahead and do one more here, and then I'm going to have you guys try out the last one on your own. So let's go ahead and take a look at this. So it says classify each triangle by its sides as either equilateral, isosceles, or scalene. Isosceles or scalene. Then determine if the given triangle is a right triangle. Justify your answers with a written explanation. Alright, well first we're going to have to go ahead and graph these points. So x is 3, 4. So write 3 up 4. And the coordinates here are 3. Just like that. Okay. And then y is 5, -3. 5, -3. This is y. And then finally z is -2, -5. -2, -5. Right down there. So that's z is -2, -5. Now I can go ahead and connect. Alright. You guys can probably do a better job. You guys can use a ruler. I unfortunately find it very hard to write or to draw a straight line on the screen, but that's my best. All right, so let's go ahead and do this. So once again, guys, what do we need to know? We need to know the lengths of these things. And in order to find lengths, I need to know, or have to use, rather, the distance formula. Again, I'll go ahead and write it down here for you guys. So it's d equals x2 minus x1 squared plus y2 minus y squared. Keep that in mind, guys. You'll definitely need this for this chapter. Okay, that's why we went over it on chapter 1. Alright, let's do this. So, xy. Again, I just like checking this before we even get started. So let's see. Alright, so x comma y. So I have, let's see, 5 minus 3. And then I have y2 minus y1, so -3 minus 4. Okay, that's going to give me the square root of 5 minus 3 is 2. So I have 2 squared plus -3 minus 4 is a -7 squared, which is going to be 2 squared is 4, -7 squared is 49. So that adds up to be the square root of 3. And again, you don't have to go any further from here. All you have to do is compare your lengths at the very end. All right, let's go ahead and yv. So I'm going to have -2 minus 3. -2, whoops, minus 3 squared plus -5 minus 4. All right, let's see what we get. So -2 minus 3 is just the -5 squared plus -5 minus 4 is a -9 squared. And then finally, we get 25 plus 81. And if you add all that up, you should end up with 106, I believe. 106. Alright, let me just double check my work here, make sure I did that correctly, guys. So I did y. Oh, never mind. That was xz. No wonder. Ha! I knew something was wrong. I'm like, those lengths definitely don't look to be around the same. Let me redo this, guys. Sorry about that. If you have that work, go ahead and write it underneath it. That is going to be the length for xz. So let's try this one more time. Alright. So this is going to be, so x2 minus x1. So I'm going to have negative 2 minus 5. There we go. Much better. Plus, and then negative 5 minus negative 3. Okay. All right, so what do I get? Let's see. This is going to be negative 7 squared plus, well, negative 5 minus the negative 3 is really like plus 3. So this is going to be a 2 squared. And then negative 7 squared was a 49. Negative 2 squared is a 4. And this gives me a 53. That is much better. All right. All right, so definitely right off the bat, I can already tell I'm not going to have a scalene because I already have two sides that are equal to each other. So this is either going to be an isosceles or an equilateral. So let's go ahead and find our last one. And technically, we already did this work, so I'm just going to run through this fairly fast. Right? It was negative 2 minus 3. And then negative 5 minus 4. This was negative 5 squared plus negative 9 squared. 25 plus 81. This is the square root of 106. So I apologize at the beginning. I realized I did that work at the top, but I just brought it down. So don't redo it if you had to. If you had to go further in the video and watch what I really got. All right, but I do want to show you guys those two are exactly the same. They're congruent. The other one wasn't. That one's a totally different one. So my question is to you guys: is this an isosceles or is this an equilateral? And hopefully you guys are saying that this is an isosceles triangle. Okay. And then just for justification here, guys, make sure you write in y, and the reason why is isosceles because two of the sides are congruent or they're the same. Okay. Awesome. Cool. All right, guys. I think this is enough of. Oh, wait. No, not quite done yet. I have to finish 2b, and then I'm gonna let you guys try out 3 on your own, guys. So let's see. It says, is x, y, z a right triangle? Yes or no? Well, again, to know that, I need to know if I have a set of perpendicular lines. And if I have a set of perpendicular lines, let me write that in. Perpendicular means I have to have opposite and reciprocal slopes. So let's go ahead and find all slopes here. So let's find the slope of x comma y comma z, or and line x, z. Yep. Let's go ahead and do it. So xy. XY, I go down 1, 2, 3, 4, 5, 6, 7, down and to the right 2. So down 7, right 2. Next one is YZ. So from Y to Z, or rather I'm actually gonna go from Z to Y. So up 1, 2, and to the right 1, 2, 3, 4, 5, 6, 7. So my slope here is 2 over 7. And then finally XZ. So I'm going to start from Z. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to the right, 1, 2, 3, 4, 5. So up 9, right 5. Now we have to check. Are any of these perpendicular? Or in other words, do I have opposite and reciprocal slopes? Well, I'll tell you right off the bat, this one right here, don't even look at that one because that one has a 9 in it. The other two don't have a 9 anywhere. But between these two, yes, those are opposite and reciprocal slopes. One of them's negative, one of them's positive. And then one says 7 over 2, the other has 2 over 7. I have opposite and reciprocal slopes. So, my justification of whether or not I do have, because I do have a right triangle, and the reason why is let's explain it. Incomplete sentences. Okay? So the triangle is the right triangle because two of its sides are perpendicular. You can just use that little symbol there. Okay? So the triangle is right because two of its sides are perpendicular. We know that because we found the slopes and we saw that they were opposite and reciprocal slopes. Okay guys, I think it's time for me to let you guys try one on your own. So go ahead and try 3A, and then I'm going to go ahead and fly through that when I get back, and I'll help you guys make sure that you have it right. So you guys can double check and compare your answers with mine. So go ahead and pause the video at this time and try those few on your own. Alright guys, so I'm going to go ahead and fly through this real quick. So if I go a little bit fast for you, that should be fine because you guys have already had a chance to try it out. But I'm going to go ahead and graph all my points here. So -5, 4. This is A. Okay. And then I have B, which is -2, 5. And then I have C, which is -3, -2. All right. Try my best here to draw a straight line. All right. So distance of AB. So -2 minus -5 squared plus 5 minus 4. And this time, make sure you are checking all your work. Make sure it matches mine. All right. So this is really a minus a negative, so it's a plus. So -2 plus 5 is 3 squared plus 5 minus 4 is a 1. So this is really 9 plus 1, and in other words, that is the square root of 10. So if you got AB, or the length of AB as the square root of 10, you guys are on the right track. Next one, BC. So this is -3 minus -2. Plus, let's see, -2 minus 5 squared. Okay, so again here, a minus a negative is really a plus. So -3 plus 2 is a -1 squared. And then -2 minus 5 is a -7. And finally, -1 squared is a 1, plus -7, which is 49, which is the square root of 50. Awesome. All right, last one. C, or AC, I should say. All right, let's see, what is AC? So this is going to be -3 minus -2. I'm sorry, -3 minus -5, and then -2 minus 4. In other words, once again, double negative here, so it's going to go positive. So this is negative 3 plus 5 gives me a positive 2 squared, plus negative 2 minus 4 is a negative 6 squared. 2 squared is 4, negative 6 squared is 36. Add those two up, I get square root of 40. Alright, so I kind of went through that pretty quick, but that's because you guys have already had a chance to try this out. So let's look at all three of our lengths. Square root of 10, square root of 50, square root of 40. They look kind of nice, but they are all different, okay? Because they're all different, we have a right? And we're going to write our justification. The triangle is scalene. Whoops. Scalene because all of its side lengths are different. All right. None of them are congruent. They're all different. Okay. So let's move on to 3b. It's asking, is this a right triangle? Well, just like before, we have to calculate what all of our slopes are and find to see if we have any opposite and reciprocal slopes, because right angles happen at perpendicular lines. So the first one it was asking for was AB. So from A to B, I go up 1, right 3. So up 1, right 3. For BC, I go up 1, 2, 3, 4, 5, 6, 7, and to the right 1. FYI, from C to B. It really doesn't matter which way you go, guys. Just make sure if you go left, it's negative. If you go right, it's positive. If you go up, positive. If you go down, it's negative. All right, so you should still end up getting the same answer regardless of where you started. All right, and then the AC. So I'm going to go down 1, 2, 3, 4, 5, 6. Down 6 and right 2. So down 6, right 2. And actually, that's going to reduce. Let me rewrite. That reduces to negative 3 over 1. And as you guys know, I like to keep those as fractions. It's going to be easier to identify in a second. So let's compare them all three of them. Well, right off the bat, again, which one do I not even want to look at? It doesn't even have similar numbers. That one right there. That one doesn't even have the same numbers. The other two do. Let's compare them now. Are they opposite and reciprocal? Opposite and reciprocal. And sure enough, yes they are. Look, 1/3 and negative 3 half, or negative 3 over 1. One of them is positive, one is negative. And then one has 1 over 3, the other has 3 over 1. So yes, we do have a right triangle. And then the reason why is the triangle is a right triangle because two of its sides are perpendicular. All right. That's it, guys. All right. So, again, let's just recap a little bit here. Scalene triangles. All three sides are different. Isosceles triangles, two sides are the same, the other one is different. And equilateral triangles means that they all have the exact same length. They're all congruent. What did we do to do that? Okay, well, we went ahead and sketched a triangle onto our coordinate plane, and we had to find the distance between each set of points. That way we knew the side lengths of each of the triangle sides. Once we did that, we were able to determine whether we had a scalene, isosceles, or an equilateral triangle. Finally, what we did was to go ahead and use that graph to find all the slopes of each one of those lines and determine whether or not we had a right triangle. Again, the only time you can have a right triangle is if you have a set of perpendicular lines. And the only way to identify if you do have perpendicular lines is if any of those slopes are opposite and reciprocal slopes. Okay? If you do have that, then yes, the triangle is a right triangle, and the reason why is because two lines are perpendicular. Alright guys, so hopefully this made a little bit more sense now that we had a chance to explore it and that you guys had a chance to try some on your own. Again, search for us, look for us, ask for help if something is still a little confusing, but for now I'm going to go ahead and sign off and I'll see you guys in the next one. Bye.